Welcome to this web lecture in which I will explain the requirements for the final project. In the final group project, we are going to design and implement a mobile room thermostat. The thermostat will be running on an Android phone, right? Perhaps also a tablet, and that is up to you to choose, and it is a prototype for a room thermostat. The thermostat will be running on the phone. It is not a prototype for a box that hangs on the wall. Right? Typically, you take your phone everywhere. You do not hang your phone on the wall. Right? It is also a prototype that runs on the phone, not in an Android simulator on a computer. Right? We must see your final project running on a phone or tablet. Right? The thermostat itself. Users can define a weak program. Right? The weak program controls the heating system through wireless connection. Note that when you have a weak program, it means that every week is the same. Users can enter and save the program on the device and also send that program to the heating system so that the heating system will start executing it. And should they install the thermostat on a new device, they can also then retrieve the weak program from the heating system. So in principle, several phones can be controlling the same program, and they can save it and others can retrieve it. Users can always monitor the status and the temperature. So you can see how warm it is in the room where the actual sensor is. The sensor, of course, is not on your phone because you may be on the road, and the heat is measured inside your house. You can change this setting. You can temporarily override the temperature. If you feel a bit cold, right, the user can increase the temperature a bit. Users can also override the temperature permanently. Well, it's not really permanently, but until you switch it off. This is used when you go on vacation. When you go on vacation, you typically set a very low temperature during the vacation. And when you're, say, on the train back home, you will use your thermostat on the phone and say, we're now returning from vacation, and the heating will start working again and raise the temperature so that by the time you get home, the house is nicely warm. There are some mandatory capabilities for the thermostat and also some mandatory limitations. Right? More functionality isn't by definition better. Right? You must stick to the capabilities and limitations. The first capability is that the thermostat knows two temperatures. We call them day and night, and they can be set to values between 5 degrees and 30 degrees. The heating cannot go over 30 degrees, and we cannot go below 5 to prevent freezing of the pipes. The values can be set in increments of 1/10 of a degree. Note that because there are these two temperatures, it means that the day and the night temperature are the same for every day in the week program. It's just two temperatures for the whole program. The temperatures thus apply to all the days of the week. But the user can create and update a week program where on each day it is possible to have these temperatures be applied to different times. So maybe on Monday you want the heating to be on and you want day temperature at 8 o'clock in the morning, and maybe turn it off and go back to night temperature at 8:30 because then you're off to work, and maybe in the weekend you only want the heating to come up by 9 in the morning because you're sleeping late. Right? So every day may have different times. It is likely that some days will have the same times, of course. Every working day probably have the same pattern. And it all depends on what the user wants. Each day may have up to exactly 5 changes from the day temperature to the night temperature, and 5 changes from night to day. So maybe in the morning there is a period where you switch to day and then to night again, and then if you come home for lunch, day temperature will come on again and night temperature after lunch, and then in the evening there's again a period with day and night temperature. You can have up to 5 such periods, each time having a switch from day to night to day and from day to night. Midnight is always a switch to the night temperature, not counted as part of the 5+5, unless you set midnight to be the start of a day period. This is possible, this is allowed. Right? Maybe you expect to stay up late on Saturday night, running in through Sunday morning until 1 a.m., for instance. Right? Then you will set a switch from night to day at midnight, and that is counted towards the 5+5. The number of switches, 5+5, is a fixed maximum. You are, of course, allowed to have fewer switches on a day, but not more. And it is 5 of each, not just 10 switches in whichever direction. And if you use fewer switches on one day, it doesn't mean that you can then use more on another day. Right? The unused switches cannot be transferred to other days. Now, use your imagination to make it easy for users to override the temperature temporarily, that is until the next switch, or to go on vacation and set another temperature. Each time the temperatures are set in increments of 0.1, so 1/10 of a degree. Vacation setting must be easy to enable and also to return from vacation. Use your imagination to come up with interface elements that make it easy. Now, regarding the implementation, we have 2 groups of students. One are the students in Eindhoven, and the other are students in Moscow. The students in Eindhoven must implement real communication between the thermostat and a heating system that is actually working as a web server using HTTP for the communication. So Eindhoven students do not implement a heating system. We will deliver a heating system as a web server that you have to use. The students in Moscow will implement a heating system, simulation of course. Right? So the heating system pretends to be running on the phone, right? And there will be no communication with a server. Generally speaking, this is easier. It's easier to have your local heating system and not worry about communicating with a server. The difference in these assignments exists because there is a different number of study points for this course. When you implement your local heating system, you must implement your own clock that runs 300 times faster than real time, so that when you're checking whether your thermostat works properly, just like we will be evaluating it afterwards, right, a week doesn't last a week, right, but we can see what happens during a week in a matter of minutes. For the Eindhoven students, the server that simulates the heating system is also using a clock that runs 300 times faster than real time. All of this means that the day and time that the thermostat will be using is not the one from your phone. Right? It is a time that is evolving much more rapidly. Now, what is required in terms of delivery? You must first of all hold and write a report on a brainstorming session. This typically includes handwritten notes, drawings, maybe you take a picture of what you drew on a whiteboard. Right? It is not a very well structured document. From the brainstorming, you end up with one of the many alternatives that is chosen, and you develop it into a prototype that runs on the phone. You can do this in two ways. You can create a Java Android prototype, so it's a Java version specifically for Android, or you can do it in HTML5. HTML combined with JavaScript and style sheets, and creating something that looks like an Android prototype but is in fact running inside a browser. Your prototype must be somewhat functional. Right. This means that the users must be able to enter a weak program, review it, change it, override temperature settings, right. Temporarily, permanently return to the program. You must also, when you activate your thermostat, be able to retrieve the program either from local storage or from the server, right? So that the thermostat that is carefully been programmed, right, can be used again with the same program. You must create a single zip archive that contains everything. The zip archive must be named thermostat dash and then your group number in 2 digits .zip. A zip archive is a file that ends in zip, not tar, not targz, not rar, right? It is zip. It contains the brainstorming report. This can be either Word or PDF. It must contain source and binary code for your prototype. And if you are running the prototype in HTML5, right, we must also know where it is installed, if it is installed on a server. Otherwise, we will run it inside our phone. You must have a README file with simple installation instructions. So there's sort of a quick start guide. Which steps to take? This is probably very easy, right? Especially when it's a Java for Android application. It's just one package to be installed. And you must have documentation for the end user. This is the booklet that typically comes with a product. It's an instruction manual. It shows the use, it has lots of screen dumps, right, and explains to end users how to use the prototype. Then you need to submit it. The submission, as I said, it's one zip file, thermostat-group number.zip. Right. It must be uploaded to the Sakai site. There is an assignment created for it. Right. You can, again, upload early versions and then later send updates. We also have an intermediate deadline where you can already submit your design proposal so that you can get feedback on it. We want only one upload per group. And you must make sure that you take a confirmation screen dump, right, that shows the Sakai screen telling you that your submission was successful. Make a screen dump, send that to your group mates, and keep it for evidence. If something goes wrong and we cannot find your assignment, then the screen dump is your proof that you actually submitted something. After you submitted your thermostat, we are going to do evaluation. This is again different for the Eindhoven and the Moscow students. The Moscow thermostats will be evaluated by us, and we will make a video recording of this evaluation so that you can actually later see how we fared. Right? You can see where we got frustrated. which things went wrong that perhaps explain a low grade that you get of this thermostat you thought was so wonderful. In Eindhoven, we do the evaluation through thinking aloud experiments with 3 groups per session. Maybe a session of 2 or 4 groups, because it's not guaranteed that the number of groups will be a multiple of 3. These sessions will be done in the exam period of quarter 4. We will schedule these later during the course, right? And until you know when your session is, right, do not book tickets for your vacation. Right? There is no excuse, right, for not being able to make it during one of the evaluation sessions. Right? You will be given a number of choices so that your evaluation session will not conflict with an exam you have to take for another course. Right? But it may conflict with your wishes to go on vacation for the summer. Well, you are not allowed to book your vacation until you know when your evaluation session is up, because you must be present during that session. I wish you a lot of success with the assignment, and we're looking forward to all your thermostats. Thank you for participating.